Welcome to Perspective Podcast. I'm Pablo Apiolazza. And unlocking the secrets of our complex world demands more than a single perspective. In this podcast, we invite you to dive in a realm with scientists, philosophers, and innovators, weave together fresh insights, forging a sustainable future for all. Today, I'm speaking with James Betker. James Betker has 15 years of experience in software engineering. He's currently working in OpenAI and has worked for companies like Garmin International, Google Innovative Applications, and many more. Their projects include developing software and firmware for radar systems, designing software features for in-dash navigation systems, and working on a security team. James specializes in machine learning, aviation, and embedded systems. James has a Bachelor of Science degree in Computer Science from UC Santa Barbara, and he also obtained his private pilot certification from the FAA in 2013. So James, thank you for being with us. And tell me a little bit about you. Where were you born? Where do you live?
Sure. I was born in California, in the suburbs of Los Angeles, and grew up there most of my life. Left for college to go to UCSB, which is just up the way, a couple hundred miles north. Beautiful area. It was kind of there that I decided that I don't really like living in a big city, and defined kind of my trajectory going forward. Shortly after that, I moved out into the mountains in California with my wife. Lived there for a few years. It was an amazing place called Tehachapi, a very small town. We had kids about 6 years ago and decided we really wanted to live somewhere where there was other kids to play with, other young families. And so we ended up moving out to Colorado. And so that's where I'm based right now, in a city outside of Boulder called Lafayette.
Tell me a little bit about your origins as an engineer. What drove you to become an engineer?
I think it's mostly just like a drive to build things. My interests are always somewhere in between like science and engineering. But I just definitely always steer towards the practical side of things. Like to me, it's theory isn't real until like you're holding something in your hands or you're actually playing with something, and that's more the role of an engineer.
And how you probably witnessed, like in firsthand, the evolution from traditional engineering into this whole new world that probably is not the new world at all for you, but for us it is, of machine learning and artificial intelligence. What can you explain me how was this transition from one paradigm to another, and what kind of knowledge is needed to migrate to it?
ML is in this weird state right now where I think it is an engineering field. I think a lot of the theories that are needed to get us to something approaching AGI, at the very least, like building something like GPT-4 or GPT-5 or whatever's going to come next, like they're already found. They're written down in papers, and really what is left is a matter of applying those theories and like actually building the programs and operating the GPUs and operating the training clusters to make these things actually work. With that being said, because it's such a nascent field, you really have to have like the motivation to go out and read the papers and do a lot of like your own work, like figure out how everything works. And I think that's where it trips a lot of people up. Like you can't just go to school and learn this stuff at this point. You have to play with it on your own. So yeah, I think if you're asking me like, how do you get into it? You go get a GPU and you come with some cool project that you want to do and you have at it.
So mainly your fascination for the subject is the main driven to reach this new industry, pretty much. So it was like it came from you that you realized that you needed this type of tools to do what you wanted to do.
My fascination in the field in general it's more fundamental. When I was at university, I was very fascinated in AI. I took a few classes. I read a lot of books on neural networks of all things, among many other paradigms within the field. But it struck me that
What year was this?
Huh?
Which year was this?
08. Well, 05 through 08. Yeah, it struck me that we weren't anywhere close at the time, though, and so I I decided to kind of focus more on software engineering. It was an easier path towards like building things that are tangible, and so that's what I chose to do. But about 8 years ago, a few years after ImageNet came out, I started, seeing all the interesting things going on and just wanted to get back into the field. It became very exciting again to me. But it's always been a passion of mine. I've always been very interested in theory of mind, figuring out how like what's in here actually works. Yeah.
There are several analogies to draw between how the human brain works and how the machine learning works, right?
Yeah, they're not direct analogies, but I personally think it's likely just some aspect of scale. Like you get enough things working together in like a concerted way, and like this thing that we describe as intelligence starts to emerge. It's very fascinating.
There's a lot of terminology that is quite difficult for people to grasp and understand, especially the differences. Can you help me articulate these terms? For example, the difference between AI and machine learning and neural networks. How can you articulate these three?
I'm sure I won't be able to do better than other folks who have tried at this question, but AI is artificial intelligence, so it's a blanket term for anything that acts as a human does, that is human generated, like human created. ML is the process of learning or training a computer to learn from the data that you give it. So you show it pictures of cats and it learns how to recognize cats from dogs, that sort of thing. And then a neural network is a specific way to achieve machine learning. So it's an algorithm that you can use to learn cats from dogs or learn GPT-4.
What other technologies or methods are there for artificial intelligence besides neural networks?
I mean, people have tried a lot of things, but nothing else really works. Like off the top of my mind, like genetic algorithms would be one option. So you can try to grow algorithms evolutionarily. You set up like a fitness function and some way to randomize agents in like an environment, and so the agents act in the environment, and if they're better, then they get kept. If they're worse, then they get killed off, and they pass their genes on to other agents. There's a big push before my time for symbolic learning, which is I'm going to butcher it here, but the idea is that you program in a set of rules, a large set of rules that define like how a computer system might work, and then the idea being if you get enough of those rules together, eventually that'll just become intelligent. I don't think either of those things have really panned out though at larger scales.
So right now, the most efficient or effective is neural networks, pretty much.
Yeah.
Okay, cool. I read in your blog a very interesting explanation of redundancy and efficiency. And you made this example with a 3-year-old. Can you repeat that for us?
Kind of catch me a little off guard here. I'm not actually familiar with.
You were saying that you're doing this method for us. My 3-year-old learns so much, and so you actually put a number on the amount of experiences that a 3-year-old could have, and then doing the analogy from.
I see. I think I know what you're talking about. I think this is like a point that a lot of people like to bring up sometimes, or in this type of discussion, is that we're really far from AGI because these machines are so much stupider than my 3-year-old or my cat or something like that. But I think it's important to look at it from a different perspective. These machines are learning in a different way from humans and cats and dogs. And so, they're going to be bad at like things that cats are very good at. They're going to be bad at things that toddlers are very good at. Toddlers are like very focused on manipulating the physical world, and our machines don't have any physical world to work with at all. All they know is knowledge, and they're very good at that. So I think that was the gist of what the blog post was going on. I think I also touched on how many samples, how much data a human belt is ingest, and like compared it to it with computers, and it's actually surprisingly close if you if you use the kind of heuristic map that I used in the blog post. It was a fun little experiment, thought experiment that I did.
I really recommend the article because it's literally an engineering approach to an idea. So let's move into generative AI, which is something that you are quite experienced with. You made some significant contributions into the audio synthesis realm, right? Because you are the author of the library Tortoise. I don't know how you pronounce that.
I think the first one, yeah.
Where did the name come from?
When I was doing my own kind of AI projects or ML projects before joining OpenAI, I had just picked up like a naming scheme based on the California desert. I spent a lot of time out there as a kid, and there's lots of cool names you can come up with. So Tortoise was one of them. I think Tortoise in particular, though, was really accurate for the text-to-speech model at the time. At the time, in that field, everyone was trying to build systems that you could deploy to like a smartphone, because that was like where the money was. Like if you could build an assistant into a smartphone that spoke to you, then you could I don't know, get some VC money or something along those lines. So nobody was thinking of it like, well, what if we just make the best quality speech that you possibly could get? And who cares how much compute you throw at it? And so that's kind of where I saw the opportunity. It seemed obvious to me that you could throw more compute at the problem and get much higher quality than what we were seeing in general. It turned out to be true.
For those who don't know what Tortoise does, you pretty much can generate voice from any voice samples. You can train your own voice and generate speech from the text that you input, right?
Right. Yeah. You give the program a few seconds of anyone speaking, and it does its best to try and replicate their style of speaking, their tone, speech traits, and then it'll say whatever you type in.
Did you expect that it worked so well at the moment you did it?
Let's see. I didn't know how well it would work when I was kind of in the weeds. There are a few versions of it. The first two that I came out with, like, it was already clear that it was doing better than anything that was open sourced, but it was not blowing me away. And I was pretty surprised and happy with where I got with the final version that I released. A bit of background, like the reason I got into this project in the first place was like, I was driving home across Colorado one afternoon, listening to a book, and I was just an audiobook, and I was just thinking, like, I really like this narrator. Like, he's a fantastic narrator. I want him to read like more books for me. How do I make that actually happen? And like at the time, I had been working a lot on image upsampling, so image generation, and it's a fairly saturated field. A lot of people are working in it, and I started kind of reading up on the literature for TTS and just noticed that like no one was actually trying to improve this quality situation, like actually make this happen. Given a audiobook reader that you really like, you can't just go out and create like more audiobooks from that person. And so for me, it was always about quality, and I wasn't happy with the quality that I had in the earlier version, and I was quite happy with whatever I got at the very end.
What is the difference in the approach of image and video synthesis and audio synthesis? Because I'm guessing also from the training standpoint, it's much easier to train on image and video instead of audio. Am I right or am I wrong? Can you correct me, please?
I think image and video are challenging. I don't think audio is actually particularly hard. I think there's just not a lot of people specialized in it or are willing to learn kind of the intricacies that come with dealing with audio. But like when you think about it, audio is just a sequence of waveforms, a sequence of like data that has like a 1D axis, which is time, which makes it much more amenable to processing the same ways that you do with text. For example, images become more difficult because you have 2Ds. You have the height and width axis on the image, and then you have to figure out how to like actually represent that to a computer that only understands 1D.
Well, there was a time that it was also one-dimension wave, the image, right? Back in the analogic TV, right?
Yeah. I mean, ironically, that's kind of how we do a lot of the image generation. algorithms these days.
So, what do you think are the frontiers in this particular sector that is audio? Have you played a little bit with music, or what do you think it's interesting in this field?
Yeah, music is something I'm very interested in. It was something I pivoted to directly after working on Tortoise and before I got hired at OpenAI. As you all know now, I worked on Dall-E 3 at OpenAI for the first year I was there. From the time that I did work on the music, I can tell you that it is a lot more challenging than speech, and it's a lot more challenging than I initially gave it credit for. The principal problem is like lack of data. For speech, it's trivial to go out and get millions of hours of people talking. It's just like all over the internet. I think it's more common than images, for example. But music is super rare to come by. I think you'd be lucky if you can get 1 million hours, and the high quality stuff is much less. It's just also very complicated. One thing that struck me working on early music generation systems is that if you build, as you approach like a good music generation systems, you get almost everything else for free. Like you can generate the sound of a lion growling or a person talking. Like it essentially seems like everything that is audio is encapsulated within music. And so if you can get
like
that,
fishing with dynamite, pretty much. Okay, so in terms of computing power, there is a huge demand for this kind of resources to do this type of research. How do you think there is any room for independent researchers to actually approach this type of research, or do you need, like, what's the outlook in these terms?
It's not horrible. It depends on like what goals you set. If you want to build a GPT-4 quality system on like less than many thousands of GPUs, you're in for a long fight, I think. But I think you have to put into perspective what OpenAI and Google and everyone is doing. What they're building are like these candidate systems. This is what things will look like for the average consumer, the average person just turning on their computer at home in 10 to 20 years. And like, let's see what that looks like. Let's play with these kinds of systems, like start building software on top of them so that when that time comes around, like humanity's ready, right? Like, yeah. So in terms of what you can do right now, I think you can build things like Tortoise. You can build pretty competitive image generation systems. I don't think we were even close to like where we could be on that front. I think anybody could go build a better version of Stable Diffusion with enough time in an iteration, for example. But yeah, I definitely wouldn't touch large language models. I think I'd leave that to Facebook. And if you're interested in that space, I would focus on fine tuning, efficiency improvements, that sort of stuff. So
what are since it's so difficult, probably you're aware of the people that got closest to this for tackling, for example, music generation. What are the most interesting libraries and researchers right now that are working on these technologies?
For music generation?
Yeah.
I honestly think the list is pretty short. Like Google's got a team called Magenta that's been working on it for many years now. They seem to be really focused on cooperating with artists in an interesting way. Like a lot of the projects they've been building have to do with generating artificial instrument data, and then that's that sort of thing. I haven't seen any efforts on their front in terms of just like generating music given a prompt or generating music given anything. And I'm not sure that sets a goal for them. Facebook, on the other hand, has a speech generator or sound generation team that does seem to be focused on something more general. They released something earlier this year. What was it called? It's skipping my mind. But you can search for Google, and it's like audio Stream or something. And it is a text-to-music generator. It's quite innovative. I think it was hamstrung by the fact that it was trained on very small amount of data, which is a principal problem here. Past that, I really don't know of anybody really being competitive in this environment.
This is an interesting segue in terms of the philosophy behind progress in your field, because, for people that it's outside of the software engineering sector, it's hard to grasp the idea of sharing knowledge and making things open source, etc., because there's a lot of the selfishness into people's activities on a daily basis, especially if they can have like a commercial result. So can you explain me the gist of being a software engineer and having the chance to build on top of other people's knowledge, and how does this actually work? Because and why do you think it doesn't work in other levels of human ingenuity?
That's an interesting question. I think the reason it works in software and not elsewhere has to do with investment. I think one of the things that originally drew me to software in the first place was the fact that I could bring my laptop out in the middle of nowhere in the California desert or whatever, and I could just start programming on it and develop something of economic value, just like a little kid, like I said, in the middle of nowhere with a cheap laptop. But if you want to build a building in open source architectural plans, well, you have to actually go out and spend a bunch of money to build a building and validate that it even works. And then this applies everywhere else. There's always a huge amount of capital investment required to build anything of a value, and so you don't get the hackers like myself kind of jumping in and being able to contribute to that environment. And when you do have the people like myself contributing to the environment, they're doing it under someone's with someone's money, and that person often wants a return and doesn't want to open it. It is bothersome to me that this seems to be the direction that AI is going. It requires a lot of capital to build these systems and optimize them, and I don't really see that changing. And I don't know how that's going to interplay with the open source world. I think we need a lot of people just investing in open source if you really want it to be open.
But you don't quite see that happening very much.
It's just not a human activity, right? To just give away billions of dollars for nothing. I think government, honestly, are the only way that something like this would happen.
So, well, let's move into your most recent work, which is generative images, and in particular Dall-E 3. I wanted to ask you a little bit about the daily life, the work in an OpenAI. Do you personally know Sam Altman, for example, or do you have any anecdotes of the work?
Sam's pretty involved in day-to-day operations. I've met him personally a few times. He actually reached out to me directly, and when I got hired, and asked me to come join, which was really humbling. Of course, at the time I'd heard of OpenAI. I was back before ChatGPT, but still when they were doing really cool things, and it had been a dream job for me at the time. It was wow, yeah, absolutely, I'll come join. I'd love to work with you guys. Let's see, you had asked about what it's like working here in team structure. Dall-E is a very small team. It's just 4 core members, and then we have a lot of people kind of helping out on and off. But yeah, that's the way a lot of things in OpenAI are done, between teams of 3 to 5 people. You'd be surprised how small.
I am actually.
Yeah, we put out this that we're a big company, but we're not. When I joined, we were well under 300 people. We're growing quite a bit now, but most of the growth is happening in our our deployment and go-to-market teams, which makes sense. Like scaling out ChatGPT is a monumental effort, requires a lot of manpower.
Yeah. And what's the general spirit of OpenAI regarding their work? Because I'm guessing that working in a company that is reshaping our whole, society, pretty much, it must be quite a symbolic burden, maybe. I don't know. You tell me.
What was the first part of that question? I didn't quite catch one of the words.
Like, what's the general spirit of?
Yeah, it's very hardworking, very intense. The folks here are much smarter than I, let's put it that way, and kind of getting up to their speed and staying on their level is a lot of work, but it's rewarding. I mean, I've always kind of, as a personal philosophy, tried to surround myself with people who are smarter than me. I think I've really taken this to the next level at this point.
Absolutely. Can you tell me what are the main challenges to solve right now in the realm of image generation?
Oh, there's a lot left. I think Dall-E 3 is absolutely incredible. It surprises me every day still. Like, we have this internal Slack channel where we have folks working at OpenAI who post like things that they've managed to find on Dall-E 3 that they're impressed by, and like I visit there every morning, and I'm always blown away by like some of the things that they're able to generate. I'm very excited to kind of get this out to everyone around the world, and see kind of the explosion of hopefully art that kind of comes out of it. But with that all being said, like, we pressed really hard on what I've been calling caption fidelity. That is like the truthfulness to the caption that the generated image has. So like if you describe in great detail, like, I don't know, a pine cone with like one spine is red and maybe it has like some words on it or something like that, and you describe where it's located and the pine forest and all the trees behind it, that sort of stuff. Like, we tried really hard to make it so that every detail that you describe shows up in the image in some way. And I think we did a really good job with it, but it's still like the model will still ignore some of the text prompts that you give it. It'll still, really fascinating thing is it still doesn't understand left from right. So if you say, put the pine cone on the left, half the time it'll still be on the right. Just so frustrating to me. It's like small things like this that I've noticed, having worked on it quite a bit. Maybe some people won't. That lets me know that, like, as far as we've come on the front of image generation in the past year, it's always remarkable to think. Dall-E 2 came out only a little over a year ago. We're still like really far from having something as robust as like GPT-4 is in the next space. I'm very excited to kind of continue pushing on that.
All right. What do you think about generative video? What is missing to reach that from an engineering viewpoint?
Investment, compute. And data. Like, you have to figure out where to get a bunch of videos from. But yeah, it's mostly compute.
So is it actually an IP problem, or is it in terms of copyright, or is it a problem in terms of hours of computing?
The way these neural networks work is you feed some small amount of data, like an image or like a string of text, into like this giant algorithm that computes like matrix multiplications on unimaginable scales against like these very small pieces of data. And like, when you think about trying to apply that to video, it becomes very challenging.
I have a very technical question that I hope people can understand on the other side. But for a professional, for a professional video or image processing pipeline, it's very important the color space and the depth of the data that is stored in an image. And what I'm noticing in all of these libraries and technologies is that there's not a particular interest, for example, linear color spaces or a higher bit depth. Everything is in sRGB color space pretty much, or similar, which is quite compressed in terms of there's not a lot of information to work with within the image, right? Is there any interest in moving into a more professional set Is it a training problem? What do you think about this type of applications?
I think this is like the really long tail of all the technologies we're creating is taking something that looks interesting like GPT-4 or Dall-E and like making it usable by humans, making something that humans enjoy using. You're totally on base that we're not focusing on generating images with proper coloration, for example. We're just trying to make images that have good text pairing at this point. But like, I don't think this type of effort is far off in the future. And what does it take? It takes data. It's going to take going out and hiring people like you to come in and like say, hey, this is a good image or this is a bad image, and this is why these things are good images. And here, let me either label it or just build a data set of really good images for you to train on. That's the solution to the problem. But it is a lot of work. Like it's easy for me to state it, but it's like millions of man hours of work, probably more than that, like at the scales of the data sets we're talking about.
And they are heavy, way heavier also, because storing an uncompressed image is way heavier than a JPEG or a PNG, right? Well, if you want, I can give a hand. Okay, let's move on. I would like to talk a little bit about common people in AI and the relationship. Of course, there's people will kill me if I don't talk about the elephant in the room and the fear of being replaced by AI and all the common angst that is around it. I wanted to ask you, what's the common word about your inner circle regarding AI? Is people excited, afraid? Do you talk with your friends or family? Do they ask you, what do you do? Do they understand what is going on?
I don't think people understood before ChatGPT. That was definitely like a pivotal moment for the entire industry that folks started realizing like this is happening, and it's probably happening sooner than most realized. Within my inner circle, there's definitely this general concern that we're stealing jobs or jobs are getting replaced, and I feel that too. I'm not gonna like sit here and tell you that like, the world's gonna be the same in 10 years. I don't think that at all. I think we will make different jobs. I think that humans will be happier and better off because of things I'm building and OpenAI is building more at large. In the long term, I am very worried about how fast it's happening. I think, if anything, that's going to be like the real problem here, is that we're going to replace a lot of jobs too fast as opposed to replace jobs at all. And I don't really have a solution for that. I think it involves working with government, which is something my company is spending a lot of time doing.
And also probably there's no point in slowing down because we're living in kind of a type of Cold War or gold race of this, right? Nobody will stop because of principles, pretty much. If you stop, somebody else will do it. Am I right?
Yeah, I mean, I generally believe that. I wouldn't give my belief too much weight on this front, but yeah, I do think it's important. I think these systems will define our value systems in not too many years, and it is important to build systems with a Western value system.
There are many opinions that are quite different, the whole spectrum in front of artificial intelligence and generative AI and all these type of technologies, from cultural backlash and disinformation and existential dread to utopia and chances of progress. This podcast aims to give a more hopeful message, but I don't know if we can in these terms. What is your point of view in this as an insider of these topics? How do you see it? Are you more optimistic or pessimistic?
I work a lot on weird generative models. What I mean by weird is not text. Most of the people in the field are laser focused on text and chatbots. I think something that really fascinates me is like, what if we lived in a world where media and entertainment was more ubiquitous and tailored to you as a person? Like, what if I was talking about how I could go out to the desert with a small computer and create a computer program. Like, what if you could go out to the desert with a small computer and create a video or some world-class music and then share it with your friends? I think that'd be a world I'd like to live in. And so from that perspective, I definitely think if we can achieve our aims, the world will be a more colorful, interesting place to live in. At least I hope so. From a larger perspective, I'm not sure where we're going in terms of like building machines that can do most white collar work by themselves. I think if you are a white collar worker who doesn't like going to meetings all day long or working in front of computers, it is a good thing that you're getting replaced, because you get to go do something that you like actually enjoy doing, and maybe you just manage an agent that goes and does your job for you, and make sure make executive level decisions for it. So maybe that is a good world, but I'm not sure that's the world we're going into. I definitely hope so.
Okay, this podcast in particular is really inspired on the Sustainable Development Goals of the UN, which are goals that we should be hitting by 2030 to live in a livable world, pretty much. Mm-hmm. And they have a really broad spectrum from ending poverty to ending climate change, or attenuating it at least. How do you think that this technology can help to achieve these goals?
Right. So I'm not a huge expert on this front. I did kind of review the list of the 17 sustainable goals before our meeting. I think near term, the biggest impact is going to come from education. I think people are really underselling how important it is to be able to talk to a computer system and get like an independent tutor that just teaches you literally anything you want to know about the world in a very intelligible and like interactive manner. Whether that's like building your own water filtration system, or learning how to grow your own crops, or how to cook food, or like any number of things that like, so from that perspective, I think just having a better educated population with access to these types of tools like helps a lot of these 17 points. I think the remaining points could potentially be improved by AI, but it would involve us like developing what is called within the field as ASI, artificial superintelligence, which is an intelligence which is capable of surpassing humanity. Like if you can build that, then you can simply just present it with a problem. Like, we have cancer. Can you help us cure it? We have global warming. Please coordinate a massive global scale carbon capture program. Like, and it will just go out and do those types of things. But like, I think I'm quite optimistic on AGI. I think it's within this decade, maybe even shorter, to most people's definition of AGI. I'm not sure where we're at with ASI. That might be another century or two. We'll see.
There's a lot of backlash. Recently, Harari, Yuval Harari, said that we were reaching the end of human culture, pretty much. I don't know if you saw this piece of information. I can share it here if you didn't.
I know.
What we are potentially talking about is nothing less than the end of human history. Now, not the end of history, just the end of the human-dominated part of what we call history. History is the interaction between biology and culture. It's the interaction between our biological needs and desires for things like food and sex, and our cultural creations like religions and laws. History is the process through which religions and laws interact with food and sex. Now, what will happen to the course of this interaction of history when AI takes over culture? Within a few years, AI could eat the whole of human culture, everything was produced for thousands and thousands of years, to eat all of it, digest it, and start gushing out a flood of new.
And I left the suspense on it, but well, pretty much the point was made. So, what do you think? Do you think he got a lot of backlash from this statement, saying that no, it's not, this is like attacking technology, and it's fear mongering, etc. What's your take on this? Do you think that creating pretty much you said that we are pretty close to creating an AGI, right? Less than a decade. Do you think that it is dangerous, or do you think we can actually control it?
That seems like an orthogonal question from whether or not it will eat culture, as that gentleman stated. To attack that one first, culture's been under attack since the internet was invented and started proliferating, since mobile devices have come out. I think if you went back 10 years and lived in that world for a couple of days, you'd be shocked by how different it is compared to where we are today. And I definitely think the same thing will happen with the rise and dispersion of AI. I don't have any doubts that our culture is going to change as a result of it. Just to say that it's going to disappear altogether seems naive, though. I think culture is a human construct built up by socializing with other humans, and to say that we're not going to socialize anymore seems incorrect to me. I'm not a sociologist. You had a second question, something around existential risk. Is that right?
Yeah, because a lot of people there, it seems like in the scientific and technological world, there's two sides right now. The people that are really concerned, some included, about AGI, and the people that is not concerned at all. Where do you fall in between these two?
I'm worried about the way people use AGI, not the software itself. I think even if it became agentic, if it's AGI and not ASI, then all it can do is approximate humans. It can become another human, or a million more humans. Now, in this world, if you are an evil person and you are given the ability to deploy a million humans to achieve your ends on the internet, I think you can do some pretty deplorable stuff. And I'm really worried about that. I don't think these AGIs are going to come along and be like, oh, we're going to kill all humans. But I am quite worried that someone's going to be like, I want to oppress this population, and I'm going to deploy a million AGIs to do so. That is a serious problem.
Okay, so it is. As always, the problem is us, not the computers, pretty much, right?
Yeah.
Okay. Well, thank you very much for all this. I wanted to wrap it up asking you if you have any, in your field, people that you admire particularly, or people that you think could be interesting to be in this podcast, for example. Pretty much a shout out to somebody that really helps with your work and inspires you on a daily basis.
No, I'm amazingly fortunate in this regard. I remember 2 or 3 years ago, I was reading the papers of all the folks I'm working with now, and just thinking of how much incredible work they're doing. But I get the blessing of being able to work with them day to day. Sure, you want to make names like Alec Bradford, Prafula Dariwal, Aditi Ramesh, my co-author from Dall-E. Alex Nicole is amazing.
Okay, thank you very much. Well, I think this is our time. Thank you so much for being with us.
Mm-hmm. It's a pleasure.
And well, To our audience, I want to thank you for being here with us and listen to this. And I hope you like and subscribe. I don't know how yet because I didn't figure that out. But it's not my thing. I just want to bring interesting people to the table and get information to you from firsthand. So I will let you know on some other channels from this. Have a nice evening, day, or night. And James, thanks again for coming.
It's a pleasure. Thank you.